Exponents and powers. Recall exponents and powers. We all know that the universe contains a huge number of stars. Do you know the number of stars in the universe? The total number of stars in the universe is a large number, which is more than 1,000 billion. We have already learned in earlier class how to write such large numbers more conveniently using exponents. Rewriting the total numbers of stars in the universe using exponents, we get 5 into 10 to the power 22. Here 22 is called the exponent and 10 is the base. It is read as 10 raised to the power 22. So we have seen one such large number, 5 into 10 to the power 22. Similarly, in our day-to-day life, we often have to deal with very large numbers such as mass of the earth, speed of the light, number of cells in a human body, etc. For ease in reading, such large numbers are expressed in the powers of 10. Observe these large numbers expressed in their powers of 10. Is there any pattern in these exponents? Observe that as the exponent of the number 10 decreases by 1, the value becomes 1/10 of the previous one. Let's continue with this pattern and go on decreasing the powers of 10 by 1 in each step. Now what is 10 raised to the power minus 1? As the exponent decreases by 1, the value becomes 1/10 of the previous value. Observe that in all these cases, the exponent is a negative number. These exponents are known as negative exponents and are used to represent small numbers in the exponent form. We can apply the same method of expanding the exponents for the numbers other than 10 as well. Let us consider various expansions of the number 2. We can follow the same pattern to get the negative exponent of 2. In general, we can write for any non-zero rational numbers a raised to the power minus m is equal to 1 over a raised to the power m, where m is any integer. We say that a raised to the power minus m is the multiplicative inverse of a raised to the power m. For any non-zero rational number a raised to the power minus m is the multiplicative inverse of a raised to power m, where m is any integer. Now let us look at some numbers and their multiplicative inverses. From this table, we can observe that to obtain the multiplicative inverse of a number given in the exponent form, we need to change the sign of the index of the exponent. We learned how to write whole numbers in expanded form using exponents. To express a number in its expanded form, we need to write the place value of each number and then express the place values in the powers of the number 10. Let us now learn how to express the non-integers in expanded form. Let us consider a non-integer 5452.12. Notice that this number has a decimal part. So to express the number in the expanded form, both positive as well as negative exponents will be used. To express 5452.12 in the expanded form, let us first write the place value of each digit. Now express each place value in the powers of the number 10. Hence we get the expanded form of non-negative integer 5452.12. Summary. For any non-zero rational number a raised to the power minus m is the multiplicative inverse of a raised to power m. To express the non-integer in expanded form, write the place value of each digit. Express each place value in the power of the number 10.